Hi, welcome to another video by the NJC Junior High Science team. Today, I'm going to show you how we can simplify circuits by using the coloring method. For more videos like this, please subscribe to the channel. Now, the purpose of simplifying circuits is so that we can, at one look, see how the electrical components are connected to one another, whether or not the components are connected in series or in parallel. If we are able to see this connection clearly, then we can calculate the effective resistance very easily using the standard series and parallel resistors formula. And with the total resistance found, we can then easily figure out what is the current passing through the cell using Ohm's law. In the coloring method, we are actually coloring the potential. And over here, you can see I ran the potential from the highest potential given red color all the way to the lowest potential given a black color. And in our shading, we will start with the highest potential, which is right next to the positive terminal of the battery. So I will shade the wire starting from the battery, and I will only stop when I hit a component over here. I will also stop when I hit the component T over here, and I will stop when I hit component V over here. And there you go. The red colored wires all have the same potential, which is the highest potential in the whole circuit. Now, next, I will shade the lowest potential, which is found right next to the negative terminal of the battery. So I will shade the wire again, and I will stop only when I hit a component. Alright, next, let's go with the second lowest potential. The blue color will be used to shade from here, and I will stop when I hit the component, and I will stop when I hit a component. Alright, the next potential, green, I will use it to shade here. And finally, yellow will be here. In the second step, we will now identify the potentials surrounding each component. So let's look at resistor V. Resistor V is surrounded by the red color wire, red color potential, and the blue color potential. So I'll just set out a table like this, red and blue. Resistor R is surrounded by red and yellow. Resistor S is surrounded by yellow and green. Resistor T is surrounded by red and green. Resistor U is surrounded by green and blue. Resistor W is surrounded by blue and black. Next, I will show you how you can do the analysis now to identify which components are connected in series and which components are connected in parallel. So let's look at resistor R and S. Notice that over here, you see that resistor R starts with a very high potential red to yellow, which is continued by resistor S, a yellow potential, and decreasing to a green potential. So this tells us that resistor RS is in series. Alright, so perhaps I will just write RS together because they are connected in series, and the color surrounding this RS resistor will be red to green. Okay, so now next we will be able to see that between RS and T all has a higher potential of red and the lower potential of green. This means that RS and T are in parallel, are connected in parallel. Alright, next, we can see that RST, this branch in parallel, RST is connected in series with U. So RST, which is in parallel, is in series with U. We can also see that V starts with a higher potential of red and it ends with a lower potential of blue. And at the same time, RST starts with a higher potential of red and it ends with a lower potential of U. So RST in parallel with U is surrounded by the same red color potential on one side and the blue color potential on the other side. This tells us that resistor V and resistor RSTU are in parallel. And finally, after blue, the last component in the circuit will be resistor W, which is in series to the battery. Now, we are now able to sketch out a simplified circuit using this analysis written out in words. So let us draw in the battery, and we keep the battery on one layer and the other components on a lower level. So I will first draw RS in series, and RS is in series and is connected in parallel to T. So let's draw in resistor T. And these two, they are connected in parallel. So this is the way we draw components connected in parallel. Next, this RST parallel branch is in series with resistor U. So let me draw in resistor U. And this shows you how RST, a parallel branch, is connected in series with resistor U. Now, as we can see here, this RST and U, this big part of the circuit, is in parallel with a resistor V. So let us draw this in, a resistor V over here, and these two are now in parallel. And finally, W is in series with the negative part of the battery. So let's draw in a resistor W here, connecting back to the negative part of the battery. And let's just double check that for resistor R, resistor T, and resistor V, the higher potential side of this resistor should be red color, connected to the positive part of the battery. So let us make the connection here, and we are done simplifying the circuit. We can do a quick double check. As you can see, from the battery to resistor R, T, and V, we should have the red color wire. So if I were to do some shading over here, this will be the case. Alright, and immediately after R, I should get a yellow color wire. After S, after T, and before U, I should get the green color wire over here. And if I look at my original circuit over here, after U, after V, and before W, I should get a blue color wire. So after V, after U, before W, blue color wire, and finally the black color wire is in between W and the battery. So now the original circuit and the redrawn circuit, the colors of the wires correspond to each other already. Now, the final step to do is to figure out what's the effective resistance of the circuit. Let's take the resistance of each resistor to be 1 ohm, and let's assume all of these resistors are equivalent resistors. So let's figure out the total resistance of Rs parallel to T. And if I plug in the equation, 1 over total resistance of a parallel circuit equals to 1 over resistance of Rs plus 1 over resistance of T. Then I will get 1 over 2 plus 1 over 1. And this should get me 3 over 2. So resistance of Rs parallel to T, this resistance of this parallel branch is actually just 2 over 3 ohm. Now, resistance of Rs parallel to T in series to U is simply just adding out the resistance. We should get 2 over 3 ohm. Alright, and then resistance of the very big parallel branch of Rs parallel to T series to U parallel to V, this super big parallel branch with the resistors Rs, T, U, and V. The resistance of this parallel part of the circuit equals to 1 over, this should get me 5 over 3 plus 1 over resistance of V, which is 1. So I should get 3 over 5 plus 1. So I will get the resistance of RSTUV, this whole big parallel branch, to be 5 over 8 ohm. And finally, my total resistance, which is the effective resistance of the whole circuit, is simply just resistance of RSTUV in series to the resistor W. So this should get me 5 over 8 ohm, which should be 1.62, just 1.63 ohm, correct, to 3 significant figures. Okay, for students with the worksheet CA4.3, notice that this circuit that you are simplifying is actually identical to the circuit in the handout before this. Alright, so notice that the last two examples in the worksheet, they are drawn so differently, but in reality, the last two circuits are actually identical circuits. So this is again why we have to learn how to simplify the circuits and make the connections between the components very easily distinguishable as either in series or in parallel. So with this brings me to the end of this video. Hope all of you have learned something interesting from this video.